Hey, Vsauce, Dominic here. But what is it that keeps me here and not up there? Is the Earth pulling me down? Or am I pulling on the Earth? Well, turns out it's both. This is because of a force known as Newton's third law, which states that every action has an equal and opposite reaction. So that means that every object with mass exerts an equal force on another object that has mass. But it's not just an arbitrary point on the mass that exerts the pull. It's the object's center of mass. See, this animation should help. Basically, what's going on is the center of mass is the average of all the points on an object, and this is because of a force known as attraction. So these two balls, the center of mass, are pulling on each other, but they're unable to make a noticeable change because their masses are so small. Alright, so we can use this equation to find the force of gravity between the two objects. So what you do, you multiply the mass of the first object times the mass of the second object, divide that by the radius between the two objects' center of mass squared, then you multiply that all by the gravitational constant, which is right here. And that is 6.67 times 10 to the negative 11. So it's pretty small. Okay, so if we plug these numbers right here into this equation, you know, we get the force, the gravitational constant, times the weight of this here car, which is 1,500 kilograms, and then we multiply it by the weight of a tennis ball, which we had. You know, we'll show it later. Is 0.06 kilograms. If the distance between those is, say, 1 meter, you know, that's over one. That radius between the center of mass is 1 meter squared. And if we plug those into our calculator right here, we'll get this number, which is 6.003 times 10 to the negative 9th newtons.
Alright, so something I want to explain before we talk about equations and finding gravitational force of a planet. Let's say we want to find Earth. What you don't do is you only plug in the mass of the planet, because the force exerted by this thing, I mean, if I do that, it falls onto the ground and it pulls the Earth, but it does it like 1/10000000th of an atom, so you don't actually plug it in because it just messes things up. So that's why we only use the mass of the planet. Alright, so here's the equation for calculating the force of gravity of a planet. See, you only do one mass, and that's the mass of the planet, and you do everything else is the same. So the gravitational constant, the radius is going to be your radius of the planet, so the distance from the surface of the planet to its center of mass, which is the core. So this man is experiencing the force of gravity, but on Earth, but we're going to find that on Mars. So over here, here's the gravitational constant. The mass of Mars is 6.39 times 10 to the 23rd kilograms, and then the radius from the core to the surface is 3,389,278 meters squared. So if we plug it all in, which, you know, handily we did already, it's 3.71 newtons, which is basically a little over a third what we feel on Earth. So that's how you find gravity of a planet. So, you know, hopefully after watching, this wasn't all Greek to you. But if it was, you know, you can just watch it over again. And as always, thanks for watching.